We're here to talk through the solution to this Nanro puzzle by Prasanna Seshadri called duplicates. You'll see not only do we have repeated region shapes around the grid, but then across many of them we have repeated numbers. And so this is a case, mentally you can do something. I'm turning on the edge helper in PenPaw tools. We can mark some of these boundaries as not being able to be crossed. And these X notes mean that only one of, but not both of these cells can be part of the Nanro. And the 6 cages a touch are a key tension in the grid. These 7s in the corner are another key tension in the grid. And these 4s that can't touch are another. But one way some people will start in a puzzle like this is just to actually mark off these, like across these X's. Once we know these are in, this is off, this is 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 in, this is off. Another way, though, the reason just to sort of mentally visualize that these X's are bad is that, like, this region in the top right, as an example, can only connect through this cell. And so this path is known for sure at the start because we can't join through the 7 region. This 6 has to join to the 7 at the top, and with this current stage of the grid, it's going to have to come through here and then reach to this cell or this cell. And if we actually look at the count from here, this is 1, 2, 3, 4, 5, 6 away, 1, 2, 3, 4, 5, 6 away. You can never take this cell and have the rest stay connected, so I have to come to here, that marks this off, marks this in. We have this as the starting stage of this puzzle. The 6 has to come up, which marks off this cell. And now we create another kind of tension. Here's a 9-cell cage that needs to have 6 cells filled in, and we can't take all of these together. We actually form 2 2-by squares in doing that. So I have to remove 1 degree of freedom here to get down to 5, and then take this as the 6th cell in all cases. That marks this off, marks these in, marks these off, marks these in. The 6 completes with this cell or this cell, never taking this one. These cells marked off marks off this cell, just again across a boundary of groups of size 6. The 6 also can't take all of these, so it has to take this and then one more across this set. Again, we need to relax the tension where we have 2 2-by-2 squares. That's why the open squares in the middle, just like over here. This cell can extend to the right across that X, so this is how this 6 completes. For connectivity, we take this one, get this marked into the grid. This 6 is going to take one of these 2 cells to connect to the rest, so that finishes this region. But if it doesn't take this cell, it doesn't connect to the rest of the Nanro. That marks this in. Now I have a 2-by-2 square that marks this off. The 4 has just these cells to get completed. So this looks like a good start on this side of the grid. I think the next key point of tension is probably across these 7s. And looking at this 7, right now I have 9 cells to go. So a kind of tension I'm looking at is like if I mark this cell in, does that cause a real issue? Well, it marks 2 cells off, and now I have to take all the rest, and that puts in a 2-by-2 square. So I think the first way I'm going to chip away at this is marking off a cell like this. Now this bottom group has just 8 cells to go, and I can't take both of these. So what I do need to do is take 3 outside that space and 1 within the space. The Nanro rule now suggests from an 2-by-2, I mark this off, mark this in. Connectivity forces this part for the 6 now. I have marked this off, and so I've got 3 plus 1 more plus these 3. Mark this off, mark this in. That looks good. Got to mark this off from a Nanro sense. Got to mark this in. I now have these 4 that are going to have to work together, and I have connectivity only through this space. And so this is now pretty interesting. This group of size 3 has 2 of its 3 cells marked. And a question across this group of size 4 is, does this connect separately, so something like this, or do these come together? And we should see where we only have 1 more to mark. If they stay separate, they force 2 more in this group, and that's not going to work out. So they have to come together, and then the only way to have these connect is to have the 3s work like so. That marks these cells in, so now I have 3 of the 4 around this group, and the start of a group here, and this still has to connect. So I can only take 1 of these, and I have to get a whole set connected. So I've got to really come through this column for that to work. I have 2 more around the 3 I can take, and these groups are effectively 3 cells away. So 1, 2, 3, those are now connected, everything else shaded off, and we're through this really interesting puzzle. So thanks Prasanna for the grid. Thanks to you all for watching the video. Hopefully got a sense of how to see the duplicate clues, blocking off regions for connectivity, some different tensions, how to fill in as many as 6 here, how to fill in as many as 7 here. That kind of look-ahead thinking is also key across Nanro puzzles and really drives to the final solution. So hopefully you got something from watching this video, and we'll see you again soon.